So this is the second part of solving equations, solving different equations, or however they call it. We are going to be solving these fractional expressions, which means we got to get a common denominator. And then we're going to be solving radical equations. So if I said to you guys, and follow along with me, please. If I said to you like 1/2 plus 3/5 equals negative 1/7. Is there a way, or let's say x over whatever, is there a way to solve this? Absolutely. You'd have to get a common denominator. The exact same thing applies when you have fractional expressions, right? We have to get a common denominator here. So the easiest way to do this, and this is not as difficult as sometimes we make it seem to be, we're going to get a common denominator between all of this stuff. So the first thing you do is you always factor everything out. This would be x plus 3, x minus 3. You want everything to be in its simplest form. So if I'm trying to get a common denominator, that means they all have to have the same thing. Do you guys agree that one of them has an x, one of them has an x minus 3, and one of them has an x minus 3, x plus 3? So if I combine them all together, that would be the combination. X minus 3, x plus 3. You guys see what I'm talking about?
Yeah.
Okay, so I have to get a common denominator. They all have to be equivalent. So I look at this first fraction. Look at everything separately. I look at the first fraction. It already has an x in the denominator. It's missing these two pieces. So would you guys agree with me? I would have to multiply the bottom here by x plus 3 and x minus 3. What you do to the bottom of a fraction, you do where?
To the top.
To the top. So I would multiply the top by x minus 3 and x plus 3. And we'll do that in a second. But it now is equivalent. So I look at this second denominator here. Compare it to the big common one we made. It already has the x minus 3. What are the two pieces that it's missing? It already has the x minus 3. The x plus 3, and what else?
X.
And the x. Okay, so I have x and x plus 3. What you do to the bottom, you do to the top. Then I look at the last fraction, and I say, okay, this one has the x minus 3 and the x plus 3. What is it missing?
X.
The x. So if I multiply the bottom by x, then I multiply the top by x. Now that we have gone through and made everything equivalent, you can cross off the bottom. It's gone. You've gone through and made equivalent fractions so they all have the same denominator. You can just cross it off. And now we go through and this just becomes a simple algebra problem. I'm going to rewrite it here. My numerator is 3 times x plus 3, x minus 3. Once we get past that first step, this just becomes algebra. Then I have minus 2 times x plus 3 equals negative 12x. Questions on how I went from step 1 to step 2. You figure out what the common denominator is, then you look at each fraction separately and you say, okay, this one has this, it needs this. Whatever it needs, you multiply to the bottom and the top. Then you look at the second fraction. This one has this. What does it need? You multiply by the bottom and the top. And now we're just going to go through and simplify. All right, first thing I'm going to do is this first piece here. If I say x times x, it's x squared, right? X minus 3 is negative 3x. 3 times x is positive 3x. Those cancel out. Then a positive 3 and a negative 3 gives me minus 9. Negative 2 times x is negative 2x. Right, so if I distribute this, I get negative 2x squared minus 2x squared. Distribute here, I get minus 6x equals negative 12. Questions? Okay, let's keep simplifying. So I have 3x squared minus 27 minus 2x squared. This has an x on it. minus 6x. And if I bring this over here, what does that become? A negative 12x becomes what?
Plus 12x.
Plus 12x equals 0. If we have x squareds, we always want to get everything equal to 0. So let's combine like terms. Let's start off with our x squareds. 3x squared minus 2x squared is what? 1x squared. Negative 6x and a positive 12x is plus 6x. And then I have minus 27 equals 0. Can I factor that? Are there factors of negative 27 that multiply to give me negative 27 but add to give me 6?
Positive 9, negative 3.
Plus 9 minus 3. So my x values are x equals negative 9 and x equals positive 3. And you guys would circle it and you move on to the next one. But we have to check our answers. When we have anything that involves fractions or square roots, we have to check. Because what can the denominator of a fraction never be?
Is it negative?
It can be negative. What number can the fraction of a denominator of a fraction never be? Can I have this? Guys, are you allowed to have 6 over 0? No, you cannot have 0 in a denominator. So you have to go back. I don't need to see a big formal check where you guys check all your answers and everything, but you need to check in your brain, because if you have a multiple choice test question or if you have something on WebAssign and it asks you to put the answers in that satisfy the equation, you have to make sure that they both quote unquote work. So I got x equals negative 9 and x equals 3. So just think about this for a second. I'm going to erase the bottoms so we can see this a little better. All right, x equals negative 9 and x equals positive 3. If I plug in negative 9 for all of my x's, watch. Negative 9, negative 9, negative 9. Negative 9 is the denominator here. Negative 12 would be the denominator here, right? Negative 9. And then 81 minus 9. Do I get 0 in any of those cases? No. So that is a solution. That works. Let's plug in positive 3 and see what happens. When I plug in positive 3 right here, that's not 0. When I plug in positive 3 here, what's 3 minus 3, guys?
0.
0. If I plug in 3 here, what's 3 squared? 9. 9 minus 9 is 0. When I plug in 3 as an answer, does it satisfy this equation? And your answer would be no. So you come over here and you say x equals negative 9 is a solution, but x equals 3 is not. This is called extraneous. You would have to some way on a test or a quiz, you can do it just like this, just x equals negative 9, leave it, and then cross out x equals 3. That's you showing me, oh wait, 3 doesn't work. But when they talk about extraneous solutions or solutions that don't satisfy the equation, you have to check. You might get an answer that says x equals 6. Doesn't matter that it quote unquote works out. You have to plug it back in, and if it doesn't satisfy the equation, if it's not true, then it does not work. It's not a solution. So in this case, you guys got 2 solutions, but only one of them is a real solution. The other one is called extraneous or doesn't work. Does that make sense? I know you guys have heard this before, but does that make sense? You don't have to go through a whole formal checking process, but you have to check to make sure that your answer makes sense. That's the hardest kind of problem that you're going to see. This one's a little easier. First thing I told you to do when you're working on these is to factor everything. So this is the same as x minus 4, x plus 2. You guys agree with me? Yes or no? Okay, so a common denominator. A common denominator between x plus 2, x minus 4, and x minus 4x plus 2. What would it be? What can I turn them all into?
X
Talk to me.
plus 2.
Perfect. X minus 4, x plus 2. So look at each fraction independently, guys. This one has the x plus 2. What is it missing?
X minus 4.
X minus
Correct.
4.
So if I multiply the bottom by x minus 4. Now look, the denominators look the same. What I do to the bottom, I do to the top, right? Look at the second fraction. It has the x minus 4. What is it missing?
X plus 2.
Perfect. What you do to the bottom, you do where? To the top. Look at the third fraction. Compare the denominators. They both have an x minus 4. They both have an x plus 2. So do you have to do anything?
No.
No. So now we just simplify, guys. What's 7 times x? 7x. What's 7 times negative 4? Negative 28. This is a negative right here, so that negative goes with the 5. So what's negative 5 times x? Minus 5x. Negative 5 times 2, negative 10, right? Equals negative 9. Now that they all have the same denominator, what can I do with the bottom? What can I do with the denominator?
Cross it out.
Cross it off. Don't even have to worry about it anymore. Now this is just a simple algebra equation. You want everything, you want to solve for x. Do I have an x squared and an x or anything like that? No, I just have x's. So move all of the x's to one side and the numbers to the other side. So combine like terms first. What's 7x minus 5x?
Two X.
2x, thank you. And then I have a negative 28 and a negative 10. Gives me what? Negative 38 equals negative 9. How would I solve this?
Add 38 on both sides.
Yep. Add 38 to both sides. So you get 2x equals what?
29.
Positive 29. And then I do what? Divide both sides by 2. So x equals 29 over 2. Now, we have to check this answer before we say, oh yeah, for sure it works. If I plug in 29 over 2, just visually look at it, guys. If I put 29 over 2 here, and I add it to 2, am I going to get 0?
No.
No. If I plug 29 over 2 here, and I subtract it, and I subtract 4 from it, am I going to get 0?
No.
No. If I plug 29 over 2 into both of these, and then multiply the answers together, am I going to get 0?
No.
So then this solution works. You're good to go. The first step of getting a common denominator and making everything equivalent is the hardest part. And then it's just algebra. And if you're not really strong with algebra, then you got to really pay attention because signs are important, very important. If you have one mistake in a sign, it messes up the entire problem. If we go over here, these are the easiest ones to do. These are the ones that we like to see these. When you have a fraction equal to a fraction, what I mean by that is it is one fraction on this side and one on this side. We're not adding fractions together and stuff like that. It's one fraction equal to one fraction. All you have to do is cross multiply and then solve. Cross multiply and then solve. So I'm going to cross multiply here. I get negative 7 times x plus 9. Cross multiply here and I get 8 times 1. So distribute. Negative 7x minus 63 equals 8. How do I solve this?
Plus 63.
Plus 63 on both sides. Good. So negative 7x equals positive 71. Divide both sides by negative 7, and you get x equals 71 over 7. It's negative. check real quick. If I put negative 71 over 7 right there, and I add 9 to it, am I going to get 0?
No.
Nope. So you're good to go. That is a solution. Everybody see that? We're okay?
I have a question.
Sure. Mm-hmm.
But like, why can you cross it out? Like, I know it's what you're supposed to do, but
Because we've made them equivalent. So it's like saying if you had 1/3 plus 4/3 equals 5/3. Right? They're all the same. So in reality, what this problem is you're adding 1 plus 4. It would say 5/3 equals 5/3. You're showing they're equivalent. So when they're all the same denominator on both sides of the equal sign, if you cross it off, that statement is still true. 1 plus 4 is 5.
oh, because it's like combined, basically.
Yeah. When you're solving, once you have all of the denominators the same, they just kind of cross each other out. Like they don't mean anything anymore because they're all the same value. So you're just trying to find the value of x. That's a good question. All right, let's look over here. The next 3. These aren't as bad. There's some rules though, so let's write down our rules. When we are solving and there's radicals involved, okay? The first thing you want to do is isolate the radical. What does it mean to isolate? We all should know what the word isolate means, especially in these unprecedented times that we're in. Isolate, what does that mean?
Make it alone.
Yeah, get it alone. Then we're going to square both sides. Then we're going to solve for x. Then we have to check our answer. All right, so the first thing you want to do is isolate the radical or radicals. Then you want to get the radical to go away, so you would square both sides. Then you just solve for x like you normally would. And then we're going to check our answer. So if I look at this first example, I like to use different colors, stuff like that, so I can visually see my radical, okay? I want this to be completely by itself. So how am I going to get this radical completely by itself? What's the first thing I need to do?
Subtract the 1.
Subtract 1. So I have 2x minus 1 equals negative square root 2 minus x. Is the radical completely by itself? Look, is it completely alone, or is there something still with it?
Still a negative.
Still something with it. How do I get rid of that negative? It's a negative 1 being multiplied. So I divide both sides by negative 1. In turn, all that does is just change our sign. So negative 2x plus 1 equals the square root of 2 minus x. Now, do you guys agree that now the radical is completely by itself? Now that it is, we're going to square both sides. When you square a square root, that cancels out. This is negative 2x plus 1 times negative 2x plus 1 equals 2 minus x. You have to square both sides. You're going to have to FOIL. So negative 2 times negative 2 gives me positive 4x squared. Negative 2x times 1 is negative 2x. 1 times negative 2x is negative 2x. 1 times 1 is 1 equals 2 minus x. Now we're just solving, guys. Combine like terms. So you have 4x squared minus 4x plus 1 equals 2 minus x. I want everything on one side. Since it's a quadratic, I want everything on one side. So I'm going to move this 2 and the x. So I'm going to subtract 2 and add x. So this is 4x squared minus 4x plus 1 minus 2 plus x equals 0. So we got a little more combining like terms. 4x squared, I have a negative 4x and positive 1 gives me negative 3x. 1 minus 2 gives me negative 1 equals 0. Now we get to our favorite thing to do in the world, factoring. Since my a is not 1, I have to say a times c. So 4 times negative 1 gives me negative 4. What are the factors of negative 4 that multiply to give me negative 4 but add to give me negative 3? Negative 4, positive 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is 3. Now, since my a term is not 1, I have to divide both factors by that a term. So this becomes x minus 1, and this becomes 4x plus 1 equals 0. These are long problems, guys. We're now going to get into stuff that's not just adding and subtracting. Like you're going to have, this is college algebra. You'll see this again next year if you're a senior. You'll see it again if you're a junior. Factoring and all this stuff does not go away. So now we're going to solve. I have x minus 1 equals 0. And I have 4x plus 1 equals 0. So I get x equals 1, and I get x equals negative 1/4. Before I can move on to the next problem, I have to check. What number, what kind of a number cannot be under the square root in order to get a real answer? Can't take the square root of a what?
A negative number?
A negative. So we need to plug these two in and just make sure they don't become negative. If I put a 1 there and a 1 there, 2 minus 1 is just going to give me the square root of 1. We're good. If I put in negative 1/4, this would be 2 plus 1/4. We're good to go. Those are both fine. Both fine. All right, let's look at the next one. We need to isolate, get this radical all by itself. So what's the first thing I'm going to do? First thing I'm going to do. Minus 16 from both sides. So I have negative radical 3x plus 1 equals 4. I still have to get that radical all by itself. It's not all by itself yet. So I'm going to divide both sides by negative 1. So I have the square root of 3x plus 1 equals negative 4. So we now have the radical isolated. We're going to square both sides. When you square a square root, it cancels out. So you have 3x plus 1. Negative 4 squared is 16. And now we just solve, guys. Basic equation. Minus 1 from both sides. 3x equals 15. Divide both sides by 3, and x equals 5. Now, before you move on to the next one and say, oh, okay, I got this one right, let's go back up here and look. If I put a 5 in here, what is 3 times 5? 15 plus 1 is 16. So I have the square root of 16, which is 4. 16 minus 4, does that give me 20? 16 minus 4, does that equal 20?
No.
No. So is x equals 5 a real solution for this problem? Yes or no? When I plug in 5, does it make the equation true? 16 minus 4, is that 20? No, it doesn't make it true. So you would cross this out and say no solution. I promise you, on a multiple choice test, letter A answer would be x equals 5. Letter B would be no solution. And a lot of you would pick this and move on to the next question because you didn't check. You absolutely have to check these problems every single time you do them. Just because it works out doesn't mean that the answer that you get is actually satisfying the equation. So make sure you guys are aware of that. Like, I'm going to say that a bunch of times. All right, let's look at the last one. This is actually one of the easier ones. Are all of my radicals already isolated? Yes or no?
Yes.
Yeah. So once they're isolated, you square both sides, right? When you square a square root, what happens?
You
Yeah, so I have 5x minus 1 equals negative 3x plus 7. Move x's to one side, numbers to the other, and solve. I'm going to add 3x to both sides, and then I'm going to add 1 to both sides. So I end up with 8x equals 8. Divide both sides by 8, and I get x equals 1. Now, before I move on to my next problem, let's check this real quick. If I plug a 1 in here, what's 5 times 1? It's 5 minus 1 is 4, right? Square root of 4 is 2. Come over here, plug in a 1. Negative 3 times 1 is negative 3, plus 7 gives me 4. The square root of 4 is 2. Does 2 equal 2?
Yes.
So then you're good to go. That's all you have to do for a check. I don't have to see that you check it, but you have to check your answer to make sure that it works. Because if you don't check, like if you didn't in this question right here, you would have got the answer wrong. So it's not that you have to do like all this extra work and write out this formal check or anything like that. Just plug it back in, do a little side work, and just make sure, yes, it works or no, it doesn't. Questions? Okay, a lot of you were not